Have you ever wondered what happens to your old phone battery after it dies? Does it just disappear? Or does it have a secret second life? The moment a battery runs out isn't the end. It's actually the start of something bigger. If mishandled, old batteries leak toxins, pollute water, and endanger wildlife. Thankfully, we've got a better plan to give these batteries a second life. Battery recycling isn't just about cleaning up. It's about powering the future. Because today's old phone battery, it could be tomorrow's electric car. Every year, millions of batteries die, but inside each one is a second chance, a hidden supply of valuable materials ready to be reborn and power the next generation of technology. The journey starts with collection, because before a battery can be recycled, it has to be in the right hands. Without proper disposal, these power cells can leak toxic chemicals, polluting soil and water. That's why collection programs and drop-off points play a crucial role in making sure old batteries don't become environmental hazards, but valuable resources instead. Not all batteries are the same. From bulky car batteries to tiny ones in remotes, each holds a different mix of metals. Sorting them isn't just about organization, it's about safety and efficiency. That's why advanced systems ensure each battery goes exactly where it needs to. Nickel metal hydride batteries power hybrid cars, tools, and rechargeable AAAs. They contain nickel and rare earth metals, but mixing them with others risks contamination. Smaller facilities sort them manually, while AI scanners handle them precisely in advanced plants. Then there's lithium-ion, powerful but tricky to recycle. Found in phones and EVs, they store high energy and need careful handling. One mistake, and they could overheat or ignite. That's why robotic arms dismantle them safely. Recycling batteries isn't as simple as tossing them in a bin. They're packed with energy. Mishandle them, and you've got a mini fireworks show. That's why safety comes first. Before anything else, dangerous charges must be neutralized to prevent explosions or toxic leaks. Once safe, the breakdown begins. Giant industrial shredders tear through old batteries, reducing them to a chaotic mix of metal, plastic, and black mass. The dark, powdery gold of battery recycling. In seconds, solid power cells turn into raw material. Shredding isn't enough. To recover valuable materials like lithium, nickel, and cobalt, recycling plants use advanced chemical processes. Think of it as mining, but instead of digging through mountains, we extract metals from old batteries. Battery recycling uses two methods, hydrometallurgy and pyrometallurgy. Hydrometallurgy dissolves metals with acid baths, clean and efficient. Pyrometallurgy melts batteries at 3,000 degrees Fahrenheit to extract metals. Together, they make recycling highly effective. And just like that, the transformation is complete. What was once battery waste is now pure lithium, cobalt, and nickel, ready to be reborn in new products. These metals don't lose quality when recycled, meaning today's dead battery could become tomorrow's EV power cell, smartphone, or even a life-saving medical device. By keeping these critical materials in circulation, we reduce the strain on natural resources and cut down on waste. Nickel and cobalt, two of the most sought-after metals, undergo extra refinement to meet the highest purity standards. Using advanced separation techniques like solvent extraction, electrochemical refining, and high-temperature smelting, these materials are recovered at over 95% efficiency, minimizing waste and maximizing reuse. This reduces the need for destructive mining, which depletes resources, harms ecosystems, and emits carbon. Recycling these critical elements helps preserve the environment and stabilizes supply chains for sustainable energy industries. The best part? This process can repeat indefinitely. The same metals can be extracted, refined, and repurposed without degradation, fueling a more sustainable future while lowering the environmental impact of battery production and supporting the growing demand for electric vehicles, renewable energy storage, and advanced technology. Recycling isn't just about waste, it's about protecting resources. Mining lithium, cobalt, and nickel consumes massive water, energy, and land, leaving environmental scars. But efficient recycling reduces dependence on mining and gives these materials a second life. Mining 1 ton of lithium can use 500,000 gallons of water. Recycling the same amount? A fraction of that. Recycling cuts carbon emissions, conserves resources, and keeps hazardous waste out of landfills. The more we recycle, the less we take from the planet. But it's not just about sustainability, it's about people. Battery recycling drives job growth in collection, processing, and advanced manufacturing. Engineers develop cutting-edge recycling tech, while workers in high-tech facilities recover valuable materials. Research teams improve efficiency, and logistics networks ensure batteries are collected safely. This industry isn't just cleaning up waste, it's shaping a smarter, more sustainable economy where materials never go to waste. Now that these precious metals have been purified and transformed into solid ingots, they aren't just sitting around, they're ready to power the future. Thanks to advanced recycling, lithium, cobalt, nickel, and aluminum get a second life, driving innovation across industries from electronics to transportation and renewable energy. One of the most impactful uses is in electric vehicles, where recycled materials create new batteries without compromising performance. Companies like Jaguar Land Rover and Altilium have already tested this approach, proving sustainability and cutting-edge technology can go hand in hand. Beyond the automotive industry, recovered materials are essential for consumer electronics. Smartphones, laptops, and tablets all benefit from recycled lithium and cobalt, reducing the need for intensive mining and its environmental impact. Companies like Redwood Materials are reclaiming these valuable metals, ensuring old devices give life to new ones. But the role of recycled batteries extends beyond personal gadgets. In renewable energy, recycled nickel and aluminum help build batteries that store solar and wind power, ensuring energy is available even when the sun isn't shining or the wind isn't blowing. These large-scale systems also stabilize grids, storing excess energy and releasing it when demand peaks, critical as countries shift toward renewables. Before recycling, many batteries also get a second life in less demanding applications. Used EV batteries, for example, are being repurposed to power homes, businesses, and even entire communities. In India, old EV batteries are providing a stable power source for rural tailors, keeping their sewing machines running despite frequent blackouts. It's a reminder that a battery's journey doesn't have to end when it leaves your car or phone. It might just be getting started. Recycling isn't just about sorting trash. It's a movement driven by individuals and communities making a real impact. In Cairo's garbage city, the Zabaleen community has built one of the world's most efficient recycling systems. Despite discrimination and poverty, they recycle 80% of the waste they collect, turning discarded materials into jewelry, rugs, and quilts sold internationally. Their work not only reduces landfill waste, but also provides livelihoods, proving recycling is both an environmental and economic solution. In Brazil, recycling cooperatives partner with sustainable brands to turn plastic waste into shoes, tackling pollution while creating jobs. Meanwhile, young environmentalists are stepping up. Srini Haltamana, an American teen, founded Recycle My Battery, a nonprofit providing free recycling bins and community education. By 2025, his group had recycled 625,000 batteries and reached 40 million people. Who knew one kid's passion for batteries could spark such a big impact? Education plays a critical role in improving recycling efforts. Programs that provide clear guidance on what can and cannot be recycled help reduce contamination and improve efficiency. For example, Ireland's Deposit Return Scheme, DRS, cut bottle, and can litter by 50% with thousands of reverse vending machines and return points. Turns out, people are more than happy to recycle when it comes with a little extra motivation. But we can't wait for someone else to fix the problem. We all have a role to play. Learn your local recycling rules, reduce waste, and support brands using recycled materials. Join cleanup efforts, educate those around you, and make recycling a habit. Small actions create big change, and together, we can build a world where resources are valued, not wasted. So let's act now, because the future won't recycle itself. Recycling isn't just eco-friendly, it's smart business. Companies save costs, generate revenue, and boost their brand by repurposing waste. ExxonMobil is investing $200 million in plastic recycling, while Waste Management is putting $1.6 billion into landfill energy projects. These moves cut waste and enhance sustainability leadership. So recycling isn't just compliance, it's a competitive advantage. The future of battery recycling is critical to sustainable energy. At the 2024 Battery and Critical Metals Conference, Ascend Elements CEO Michael Cronley highlighted rapid advances in EV battery recycling, emphasizing its role in meeting rising demand while reducing environmental impact. Battery recycling is set to revolutionize sustainability by reducing reliance on mining and securing key materials like lithium, cobalt, and nickel. As demand for EVs and renewable energy grows, advanced recycling methods are making material recovery more efficient and eco-friendly. With automation and AI improving sorting and processing, recycling will become faster and cheaper. As industries and governments invest in regulation and infrastructure, battery recycling will drive the clean energy transition, ensuring a circular economy where old batteries power the future. Battery recycling isn't just about solving today's challenges. It's about shaping a cleaner, more sustainable future. From cutting-edge innovations to ambitious global policies, we're seeing a shift toward a circular economy where batteries are built to last and materials are continuously reused. The efforts of industry leaders today will define how we power tomorrow. If you found this discussion insightful, don't forget to like, subscribe, and share your thoughts in the comments. And stay tuned, the future of energy is evolving fast, and you won't want to miss what's coming next.